In this video, we will be looking at A-Level Maths topic 7, and that is logarithms. As always, these notes will be available on my website, which is linked in the description if you would like to buy a copy. And without wasting any more time, let's get into topic 7.1, Introduction to Logarithms. So, logarithms, or logs for short, are used to find an unknown power within an equation. And this is probably something you would have found quite useful at GCSE when dealing with topics such as compound interest. For example, 3 to the power of x equals 29.2. That would be an example of an equation where logarithms would become very handy. The best way to remember how logs work is the following identity. As you can see written down here, a equals b to the power of x is equivalent to log to the base b of a equals x. There are some other useful tips on the bottom left of the screen, so please pause and have a read of those to make yourself familiar with them. But let's have a look at the questions. So evaluate log base 3 of 27. So I'm going to refer to our identity that we have on the left hand side. So if we think about the letters that we have here, the b from the identity down here is a 3. So we can say b equals 3. And the a here is 27. Now, if we substitute those into the left-hand side of the identity, we can say that 27 equals 3 to the power of x. So to the power of what, basically. And we know just by looking at that, by a bit of trial and error if you want to, that x is equal to 3. And that will be your final answer there. So 3 to the power of what makes 27? We can apply it to question B as well. So 1b, log base 4 of 1 over 64. We know that to get a fraction, we need negative powers. This is where your indices laws become really useful. So please remember those. If you haven't seen that video, it is in this series already. Please go back and watch it. This one, 4 to the power of something equals 1 over 64. And we can say that that x is going to be minus 3. Because the negative gives the fraction, 4 to the power of 3 equals 64. Likewise with this one, we can actually write this one as log base 5 of 1 over 5, and that is the same as saying 5 to the power of x equals 1/5, and using a similar argument to 1b, we can say that x equals minus 1, because again that negative gives the fraction, and 5 to the power of 1 is 5. Next, we can use a calculator, so go ahead and grab your calculator. And in that calculator, find the ln button, so ln, it should be on there, and put that into a calculator. And the answer I got is minus 2.303 if we're going to 3 decimal places. And likewise for the bottom one, we need to find the button that often looks like this. It's log with one square and then a bigger square, because this time we have to put in the base ourselves. If we put that in, we're going to get minus 0.683. And that is going to be our final answer to 3 decimal places. Moving on to 7.2, the laws of logarithms. So a lot of these are literally just identities that I recommend you remember. And I do have 2 questions we can attempt as well. So going down from 1 to 4, number 1 is the idea that if you have 2 things multiplied together in one logarithm, you can separate them out so that they add together as long as the base is the same. Number 2 is a very similar idea, but with division, and they lead to subtraction of the 2 terms. The final 2 are slightly different, and the third one is definitely very useful, that if you have a power within the brackets of the logarithm, you can bring the power down to the front, and it acts as kind of a multiplier. So it would be k times log base a of x. And finally, number 4, similar to those indices laws, anything to the log of 1 is equal to 0. We have some other useful identities on the bottom right as well, and something that is very useful to note at this point is ln is the natural logarithm. So it's the same as log, but it's log base e, which is what we write as ln or ln. And they have a very similar idea, so that the ln of e cancels out and you're left with the power. That is a headache to get your head round, so please just bear with me on this one. It does take time, but it will be worth it in the long run. So simplify 4 log x plus 3 log x. Again, if we look at our identity number 1, we can see that it's kind of the reverse. So we've got 2 things that are the logs of the same base, and they are currently being added together. So we can aim to put them back into one thing so that they're multiplied together. However, because of the 4 and the 3 at the moment, we need to remove them somehow. So we can use point number 3 here and raise the powers back into the brackets. So what we can do is log x to the power of 4 plus log x to the power of 3. Another useful point to make is if there is no base down next to the log, we can assume it's log base 10. Another useful fact that is worth bearing in mind. So now we've got this, we can multiply those two things together. So this is going to become log of x to the 4 multiplied by x to the 3, which equals log x to the 7. And that is our final answer in this case. You could technically write that as 7 log x if you wanted to, but that is absolutely fine as an answer. On to question number 2. Solve log x plus 5 minus 1 equals log x minus 1. A little bit trickier, but let's first of all get the logs on the same side. So log x plus 5 minus log x minus 1 equals 1. And then based off our rule number 2, because they're being subtracted by the same log at the moment, we can write them as a division of each other. So we have log x plus 5 over x minus 1 equals 1. Because this is log base 10, to do the opposite of a log base 10, we can raise it to the power of 10. So this is going to be written as 10 log x plus 5 over x minus 1 equals 10 to the power of 1. I've written it in full form so that you can see it, but this is the same as this point number 2 over here. You can see that our a here is 10, and what that means is the 10 and the log to the power of will cancel, and you're just left with the bracket. So that's going to leave you with x plus 5 over x minus 1 equals 10, and then we just need to rearrange this to get x on its own. So we're going to have x plus 5 equals 10x minus 10. If we multiply that by x minus 1 and bring the fraction up, we can then bring the x onto the right hand side, so they subtract to make 9x, and on the left hand side we have a 15, which leaves us with x equals 15 over 9, or 5 over 3, and that is our final answer there. Moving on to 7.3, which is solving exponential equations. The main application to logarithms is solving for an unknown exponent or power. As we discussed at the start, that is what it's used for. Again, as we said at the start, it is very important to remember the relationship between converting between the a equals b to the power of x and then using the logs, basically rearranging that first equation to make x the subject. So let's put some of those ideas into practice, looking at question number 1. So firstly, solving 6 multiplied by 7 to the power of 3x plus 1 equals 1.2. You have to think of the 6 and the 7 to the power of whatever as two different things here. And the first thing we can do is divide both sides by 6. So that's going to leave us with 7 to the power of 3x plus 1 equals 1.2 over 6. And if you put that into a calculator or just work it out in your head, you can see that that will give you 1/5. As your answer to step number 1. Now, this is the important bit, and it's important to use this relationship from the identity here. The b is our 7, and the x is the 3x plus 1 as the power. To bring the power to be the subject of the equation, we take the log of 7 of both sides. So we're going to have log base 7 of 1/5, and that is step 2. Hopefully that makes sense. Again, if you don't understand that, spend some time learning the relationship of this identity. I know I've said it about 10 times in this video. It is very important. It makes up this topic entirely. From here, it's fairly simple. Just solve the equation. 3x is going to equal log base 7 of 1/5. Take away 1, and then x is going to be 1/3 of all of that. And if you put that into your calculator, you'll be able to get your final answer. Sometimes they might want it in exact form, which that is perfectly okay. Sometimes it's a bit cleaner to write it as a decimal or a fraction. And that gives an answer of minus 0.609 if you wanted it as a decimal. Moving on to question number 2. So here we need to solve an equation where you've got differing powers on either side and also different bases. We've got a 2 on one side and a 5 on the other. A classic example here is where we just take a general log of both sides. So what we can do is take the ln of 2 to the 3x minus 1, and whatever you do to one side you have to do to the other, just like with any equation solving. So we do this. You could also just do log normally. As long as you do the same thing to both sides, it's absolutely fine. So using our laws of logs that we learned in the last slide, if we have a power within the log itself, we can take that power and put it in front of the ln, or the log. So this is going to look like that. So 3x minus 1 in brackets ln 2 equals 2 minus x in brackets ln 5. What we can now do is expand that out. And once you've done that, the next step will be to have the x's on one side and the numbers on the other side. Because you have to remember 2 ln 5 and ln 2 are essentially just numbers. You could put them into a calculator and they will give you a decimal. So that's what that would look like. Now, this is the key trick here, and well done if you've already spotted this. To get x on its own, we can factorise the left-hand side, and that will leave us with just one x on the outside of the bracket. So that's going to look like x bracket 3 ln 2 plus ln 5 equals 2 ln 5 plus ln 2. A good next step is to reverse the power rule. So if you have, for example, a 2 ln 5, we can write that as ln 5 squared, which is the same as ln 25. And likewise with the 3 ln 2, we can actually write that as ln 8 now, because ln of 2 to the power of 3 is 8. And using the idea that when you have the same logs or the same base logs, if you're adding those two things together, you can put them into one log and multiply them, which is the log law number 1 that we saw on the previous slide. Please go back and check it if you want to. So that would simply be x ln 40, because we've done ln of 8 times 5, and then equals ln of 50 because 25 times 2. So if we take that up to the side up here, all we have to do then is divide them by each other to get x on its own. So that is going to be ln 50 over ln 40. And that is our final answer. We can leave that as it is, and that is in exact form. So really well done if you've understood this question. If you don't, please let me know down below. I will be happy to help. And that sums up topic 7, which was logarithms. Thank you again for watching. I really hope you found this useful. The topics are definitely getting harder and harder now as this series is going further and further into the specification. But thank you, and I will see you in the next one.